Or they said she. Good morning, everybody. If you could start moving up toward this room and be ready for our next guest speaker here in a few minutes. Understand the General Assembly is still going on, so we may hold up a few minutes for some of those members to join us. But for those of you here, if you could please move up and start getting seated, we'd appreciate it. We'll probably start in around 5 minutes or so. Good morning, everybody. We're going to go ahead and get started. Okay. I would like to ask Dr. Q King to welcome our next guest speaker up to the stage. William Woon-Sung Lee is CEO of SK Hynix Semiconductor West Lafayette, LLC, and has succeeded in developing products using TSV through silicon via and WLP wafer-level packages. The original technologies of microelectronics packaging and mass producing them for the first time in the world in 2013. Typically, high bandwidth memory, HBM, products have been successfully fully automated mass produced since 2020, and SK Hynix has contributed to solidifying its #1 position in the HBM market. Please welcome William Woon-Sung Lee to the stage.
Thank you very much. This is really my honor to present the semiconductor technology and semiconductor industry, and also some special products of our SK Hynix AI memory to the World Building Congress. It will be better to think about that. Just me as like an architect. So I'm really talk about that. So in the semiconductor industry, just changed in this year change for the AI era, and also so many. So we just called it also same words, architect. So really this time, a semiconductor industry, a semiconductor engineers who just majored architect. Architect is just very important. So that my title is just a heterogeneous integration. But so this concept is just confused. But as very simply think about that, so just like our semiconductor engineers for the heterogeneous integration, they are just making a miniature for the buildings. That is very simple concept. Firstly, I introduce our SK Hynix. SK Hynix is just a semiconductor manufacturing company, and also we have designs and so development and so manufacturing facility. So we just our business is just globally spread out. In 2024, SK Hynix is ranked about the semiconductor manufacturing industries, just ranked #4. But this is not important. But this year, around 33 years, SK Hynix jumped up the global #1 position in the DRAM market. And so this is just very, very important for us, because so always we are just ranked #2 in those kind of 33 years. But this year we just overcome those kind of very big barriers to the #1 position, because we just lead about those kind of new technology. As I mentioned about the architect, those kind of semiconductor building technology just makes us as a #1 position in this year, 2025. I'll talk about this kind of story in this morning. Our company just globally presence is just worldwide as business in semiconductor industry, so that also our product is just mainly DRAM and NAND flash. We just manufactured memory devices by using semiconductor technology. And also, I'm here just for kind of new project for our SK Hynix, just first time in the West Lafayette area, we have built our heterogeneous integration 12-inch wafer level fab. We are now operating with in South Korea, also China and Japan, very a lot of places, and so that these days we just focused on the AI memories. This is just kind of very so simple story about that. In these days, semiconductor industries just come from the three guys from very distinguished scholars as R&D guys. And firstly, Gordon Moore, as this is a very important people. Also, he's also founded Intel, and also he's the CEO of Intel. He just solidified this kind of semiconductor industry business. He's really interesting people. Also, he's just, I think, that really genius for that this kind of semiconductor. Also, he just forecast in earlier 1965. We semiconductor engineers, we always just kind of repeated. So talk about that the Moore's law. Gordon Moore's talk about that. So every 2 years or every 18 months, the transistor integrate 2 times higher. This is a rule for the semiconductor industry. So that these days, every years or 2 years, we have to buy so same electronic device, notebooks, smartphones, around 2 or 3 years. Every time we have to buy a new one because the functionality is just very different from each other. And so that so those kind of just comes from Gordon Moore's law. 18 months or 2 years, transistor integrated density capacity is just 2 times higher. That means that so every 2 years we have faced to the new era for our life and our industry. And also this just kind of architects, all architects are here as you are just using CAD. And also these days AI supportive, so many simulated tools. This is just a semiconductor industry. And also around 50 years, semiconductor industry, we call it every year, this is a leading edge technology because that, so we have to more integrated transistor into same territory. And also Jack Kirby, who invented integrated circuit, as we are now using so those kind of integrated circuit in the silicon wafers. And Daewon Kang, who is a Korean scientist who worked for the Bell Lab, he invented metal oxide semiconductor field effect transistor, MOSFET. So I do not explain about this kind of MOSFET in this time, but this MOSFET is very important for that, our manufacturing, semiconductor manufacturing by using silicon wafers. This MOSFET gives our so very fascinated process profile using silicon wafers. And these 3 people is just a very so just kind of so distinguished people in the semiconductor industry. 2 Americans and 1 Korean. And so we are now, as SK Hynix, we will build our new plant for this West Lafayette area by using new technology by just come from your architect to our semiconductor architect in this area, we will make a new era for that AI memory. And so traditionally, this is a very so simple things, but our process is just very complex, and so many people they would like to separate so 3 areas for that our semiconductor manufacturing process. The firstly, wafer manufacturing facility. That so means that the single crystal silicon wafers is just very important, and so that this area just manufacturing wafers. And the other 2 kinds of so plant is just so that is just that by our area. The first thing is a fabrication plant. We call the front-end fab. That means that just only use one single wafers, and then we embedded a lot of circuits in it there. Fabrication plant. So, and the other is just assembly and test facilities. Assembly. So we just called another terminology packaging. So this is just a very simple thing. Just packaging. Yeah. So and then so test. The product is just well made or not by using this kind of test. But these days, we have a very big challenges to this fabrication plant. And then we are now using architect by using this kind of assembly. And this is very also a simple so diagrams for that. We remember that around 1980s, 1990s, just kind of very old-fashioned computers. And so 2000s, remember that smartphone, 2010s. So really, 2010s, so really so advanced smartphone, just kind of Apple iPhone or the others, very a lot of mobile technologies just come here. And 2020, this year, we faced the real AI era. Just come from ChatGPT or the other things. It's just these days, as you are now using your smartphone, so most kindly, so software just installed AI functions. But this 2020, we do not have a kind of operating by using just only front-end fab as this like this. We need a new technology, this kind of assembly, building technology. And so this heterogeneous integration technology is just come from this area, assembly area, because that, so front-end case, the innovation flow needs a very long period. That means that the science and so more fundamental technology is just jump up the next generation. But this assembly area is just very need short time. We have to make a lot of so revolution by using this kind of so building technology. It's like this. I will explain about this kind of heterogeneous integration area. We just build this component, very lot of different functions component. We just build it like this. This is like look like a buildings, architect. I'm unfamiliar with some kind of so building or architect so theory, but I always look around at so traditionally very so beautiful construction buildings in our history, and so I found that three principles of the architectural engineering: the structure, function, beauty. That is the same three principles for our semiconductor new technology, heterogeneous integration. We just stack semiconductor device as like this. And also, so many people that this is just very stupid things, more than 10 years ago. Because that we have no method to interconnection by using our traditional method. And then so many semiconductor engineers just make a new idea. That is not new idea. We just kind of resemble, just kind of building architecture. We make just kind of this kind of new functions. We call that through silicon via. Just drilling the silicon wafers and directly. And then, so this scale is just very, very, very big scales for compared to our integrated circuits metal lines. And through silicon via, we just kind of developed this kind of new technology. But this is not new technology in the concept of the building architecture. We just develop these kind of things, and so that directly interconnect with different chips, and finally we control very high speed integrate circuits in the base die, and finally this building is working on one chip, one silicon chips. And this is just like a very high tall building, just building. This case is just HBM3E 16 high. This is the world #1 products in our SK Hynix. We just announced in the 2025 in this spring. This is the first time up. Structure, function, just like this. But how about beauty? That is not pretty, yeah. Just only like a blocks, but we just make a very beautiful interconnection or components, circuits. This beauty just come from those like this. If we have some kind of missed our process in this very complex process, but by during this just like building like just component, then we have a very ugly shape from in our process. And then this our new heterogeneous integration, introduced very lot of metrology and inspection tools in these days. This is a complex thing, but this new technology just makes the HBM3 or HBM3 case is just using this kind of new technology, and so that this case gives a lot of benefits. So memory bandwidth around 18 times more higher. Power efficiency is just very efficiency is just saving the power around 70%. Heat dissipation case around 20%. And so that gives a data center case, as you know about the NVIDIA's new GPU, they need our HBM. Finally, semiconductor engineers just kind of make a new terminology, a chiplet. A chiplet means that there's different chips just assembled by using, as I mentioned about those kind of TSB or the technologies. This is just like a architect. And so these days, so many electrical computer science or who major those kind of fields, they are now researching about that, this kind of heterogeneous integration. Also, we call that they are architect for that semiconductor. So this architect area is very important, important, and also so many big companies, they are now founding out that those kind of workforce for that who majored architect for the semiconductor technology. And I return to the former explanation about that. Just front-end fab as big challenges. This is just a CMOS transistor shape. But as you see about that, the newspaper, around the 3 nanometer or 2 nanometer case is just our just very advanced technology for that foundry business. But this CMOS is just a PN N-type transistor just combined just like a set. We have to shrink it like this. But these days, 3 nano or 2 nanometer scale, so metal line width is just so important for us. But scaling down is really, really difficult. Because this is like a photo. As architect, you are very familiar with the photo, right? Every time you just shot the buildings, pictures, and you research about that, those kind of things. But also same thing in our semiconductor. So camera is just very important. This is like a camera, which called the lithography process is just important. We have to very, very small scale wavelengths, and so these days, extremely ultraviolet technology is needed. But this equipment cost really, really expensive. Just one equipment these days, $0.5 billion. We need a very lot of equipment for our manufacturing facility. How to ensure those kind of budget? Finally, these days, very few companies just alive in this area. So, as I mentioned earlier, that Gordon Moore, Moore's law, he just 1965, his Moore's law's paper, he just mentioned about that. It may prove to be more economical to build large systems out of smaller functions, which are separately packaged and interconnected. Yeah, this is just a heterogeneous integration. He just forecast earlier than 1965, but during these days, from since then these days, we have developed also very lot of equipment, materials, process, circuit designs. Those kind of things is just developed, then we just accomplish it, a new technology in these days. So I just showing you some examples. This is just AMD's CPU, and they just developed as like this, just one chip for 32 core in a previous time. In these days, they separately 4 types, and this die is just kind of 8 cores. Then this 8 cores wafers yield is just jumped up. That means that they just using low cost for the fabrication. And also these days AMD Ryzen series is kind of separately things. And also this is the Apple M1 CPU. This case, CPU here, and DRAM is just located in very vicinity area, and they package it just like just one package. That gives a very lot of functionality. And also, this is a new hero for this AI era. So NVIDIA's A100, H100, H200. So these years, so B200. So those kind of things is just come into this AI era. So this architect is just like this process, and our HBM just interconnected by using some the other silicon interposer. And so this is some complex system, but so these days, this gives a very high efficiency for that GPUs, very lot of calculation. Multi-calculation so needs our, so these days, so biggest model for that AI. So these days, this kind of heterogeneous integration, so semiconductor, so technology is just really so very well so developed, so industrialization by TSMC. Also, they call so very lot of terminology for that, this kind of so structure. And so SOIC, INPO, COAS is just a very so big titles in these days. This kind of new architecture by using TSB, so just give us a very good signal defined so result, which just call that this is a eye diagram, but the signal is just very definitive, so different each other. And also the power delivery network is just very well so operated by using this kind of new technology. And also the other thing is so this kind of noise. This is a very high speed so signal case, and so because so those kind of high speed case only just metal lines, but the metal shapes or metallized just kind of complexity, it gives the other different results. This power noise is just very important for our functionality. And I think that so many architects, so they are now using Apple Mac Studio, because this is a very so good computer for that designs, and so that so simulated or many lot of things. In case of this case, a 20-core CPU. But these days, our front-end technology, by using just one single wafers, that case, we have to make just one chip in this kind of 20-core CPU case, that the yield is very low. And these days, this Apple M1 Ultra case, just two chip is just different two chips combines, like this new technology. We just call that some special interconnection also methodology. And this kind of building technology, this architecture, so just important thing is just that the channels, communication channel is just very needed, a very wide I/O input and output. So it's just very wide. I/O is just needed, and or just kind of so architects, many lot of so technology is coming into this area. So we have to very well so align or design those kind of things, heterogeneous integration. And then finally, we help to eliminate those kind of some noises as like a crosstalk, channel loss, or channel the other. So many lot of this kind of abnormal also phenomena. And so this is just a very near future technology for that this kind of heterogeneous integration. So these days we are now developing so research and developing by using hybrid bonding. Still these days we are using some so this kind of solder bumps for the interconnection, but this kind of interconnection so some media just gives a very so complexity issues for these kind of between the gaps, and so we have to eliminate these kind of gaps by using this hybrid bonding. That means that so this hybrid bonding is just only contact to copper and copper, and then we just push it to the pressure and heat, then copper just bonded. This phenomenon is we call the diffusion, and so that this case is just a very big so benefits for our manufacturing process. And then these days, if you use AMD CPU in these days, AMD CPU case, new AMD CPU just kind of a lot of cache memories in the CPUs, 19.6 megabyte. So just only one single wafer process case, 32 megabytes. So circuit designed on it, but they just give to bonded another SRAM chip as like this, and so finally 96 so megabyte L3 cache. So gives us a very high speed and very multifunctional also functionalities. And those kind of heterogeneous integration is just by control very precisely by using 12-inch wafer level fab. And so that this is just our 12-inch wafer level fab. So this is just very schematic, so old-fashioned fab. So as you just think about that, this is like some refrigerator. This is just a refrigerator. So we always maintaining same temperature, same humidity, and so there is a very clean room. Maintaining is just very important for those kind of very small scale process. And these days, AI so memory needs very rapid data processing and high capacity. Energy efficiency is just very so necessary so elements of our AI memory. And then our SK Hynix, we are now so just kind of solidifying in this AI memory so field. We call the high bandwidth memory, HBM4. We are just firstly introduced HBM4 memory in this world in this spring. And also the other so low power memories by using these kind of things, and we will also just provide to our customers in this year. And so customer memory platform for the AI is just kind of high bandwidth memory and high bandwidth of peripheral logic by with us, so our customers. This is just so our expert concept, and so I skip this kind of explanation. And our HBM working by with a GPU as like this, as I so explained about that. So this is our so memory stored device, and our logic die just control all these things by using this kind of TSB technology. And this is just a very so precise defined by using semiconductor manufacturing technology by using the silicon wafer it produces as like this. Our HBM is just that we just developed with AMD on 2013 in the firstly in the world, and finally, so HBM3 in 2020, HBM2E 2020, and since 2020, we just kind of so we are just positioned the number one providers in the world in this kind of new high bandwidth memory area. This high bandwidth memory, as I also mentioned the first time of this presentation, by using this kind of TSBs. But these TSBs numbers around 7,000 or 8,000 in these days, just one chip, not one wafer, one chips. And this kind of, by using bump for the interconnection, and then this interconnection is just kind of very important for that architecture. And these days, we are collaborating with a lot of companies, and so that memory makers, SK Hynix, Samsung Electronics, Micron, we are just manufacturing high bandwidth memory. So the other our customers, NVIDIA, Google, or the other many big guys. So we are just working together for these days, this year, 2025. So HBM4Ks, our customer, they designed in some areas of our base die. And this is a new era for that business model in our memory industry. And TSMC and Samsung, Intel, they are now also foundry business, so system on chip. They just manufacturing process. Also, they service this kind of integrated with the so we call that heterogeneous integration. And these days, our SK Hynix, just kind of hard to say about that. Our own unique method for the high bandwidth memory manufacturing process, we call that master leap flow and molded on the field technology. We are using this technology just only by our SK Hynix, not the others. Our competitors, they are now using the other methodology. And so we just, by using this kind of method, we just making so our product is just positioned number one in these days. And this is just very simple graphics for that our next generation products, HBM4. HBM4K is just around that very high capacity, very high bandwidth, because that HBM4 has 2048 input and output numbers, but still we are now using HBM3E 1024 IOs, and so that is a very different products. And this place, West Lafayette, as we are now progress to build our new fab, a 12-inch fab for the high bandwidth memory manufacturing packaging fab, and also this is advanced packaging means that heterogeneous integration. Our R&D fab, we just build these kind of things, and so that we are now also focusing about that as a new technology for that our next generation of this kind of heterogeneous integration with collaborating with other Purdue and a lot of high excellent as university or federal government's research center And so that this place is just very big opportunity to our SK Hynix. And we are now targeting mass production, just the first mass production at 2028, second half. And then we hired 1,000 people in the first our fab in here. And this West Lafayette, new plan give our SK Hynix new opportunity to keep the high bandwidth memory #1 player. And also, technical leadership, we have to make a very lot of new challenges. And so we have to found out that some solutions by using these new fabs. As this kind of R&D collaboration give us very new answers, solutions. So those kind of things will make keep our leadership in AI memory in this era. Also, this is very big missions to me. We have to build new semiconductor ecosystem in this Midwest triangle because still there is a few ecosystem exist here. We have to build a very big ecosystem build here. And also workforce. We are now developing with lot of educational courses with so many educational organizations in this West Lafayette or Lafayette area. And the customer, global academia, industry partner, this kind of collaboration is just our future technology will make those kind of our opening to SK Hynix as a future. Also, West Lafayette area will make us together new era for the Silicon Heartland. And also, we are focusing about sustainability in these days. We just call the PRISM as pursue, restore, innovate, synchronize, motivate. Those kind of a lot of value to the society and some environmental issues. And so it's responsibility for that, our engagement to the society. That it gives us a very a lot of big benefits for our SK Hynix development. So these days, partnership, we call that just one team spirit. So it gives us a very global success, so that we are just stepping in the first step in this West Lafayette, and then we'll big leap by together in the future. Thank you. Thank you very much.
Thank you very much, Dr. Lee. Now open for the floors to have a question. So given the limited time, I will limit 1 or 2 questions for Dr. Lee.
Dr. Lee, thank you for your presentation this morning. I think we all take for granted what goes on in these little phones of ours, so thank you very much. My question revolves around choosing West Lafayette. You talked about Purdue University was a draw here to choose West Lafayette as your site for this next major move, but Indiana maybe isn't known for their chip manufacturing, with Arizona and Oregon and other places, California. What were some of the other things that were appealing to come here to West Lafayette? As many of our attendees know, we're kind of in the middle of a very agricultural cornfield area. So what were some of the other items that were of interest?
Thank you very much. Yes, so that is just very important questions. And so I have those kind of so questions around 10,000 times more. Yeah. So many people are so wondering about that. Why do you select the West Lafayette? But 3 years ago, our project just beginning at that time. We just compared this so a lot of states in the America. But this Indiana state government and Purdue University and a lot of organizations of the Indiana's Hoosiers, they suggest very excellent conditions for us. This is a new technology, not the traditional semiconductor manufacturing facility. This is very, very new, emerging technology. As I mentioned so many times, heterogeneous integration. This place is just a very, very excellent place for our future. Those kind of reasons leads to us by a final conclusion to select this area. And so these days, we got a very big love and supportive, and a lot of collaboration. We feel like a family like this area. This is just a very big opportunity to South Korean company. Yeah. As I mentioned earlier, so 2 Americans and 1 Korean scientists, they just explore this new semiconductor industry. And this area, Hoosiers and Korean company, and American and Korean, we collaborate new era for the AI from this area. Thank you.
We're very looking forward to the opportunity to collaborate industries to provide much opportunity for the student. I'm very glad that SK Hynix provide the opportunity for Purdue University here local. Given the time limits, we prepared a small token as appreciation of the SK Hynix Dr. Lee's time. Here's the. Thank you very much.
Okay, Brian Hubbard's got a few announcements to make, so we get started here today.
All right, thank you again, Dr. Lee, and we're excited to have SK Hynix here in town, so great partnership. I do have a couple of things to announce. First of all, exhibition hall. We do have exhibitors here. They are through this door and off to the left, okay? When you're out in the main registration area, off to the left, there's some great exhibitors there. So there's ACCE is here. They've got some publishers in here that are, for journals, books, those types of things. And there is also coffee and refreshments in that area. So please take advantage of that. It's a great place to grab a cup of coffee, meet, and talk with some of our exhibitors, okay? Next thing, today is our industry day. And we had SK Hynix kick this off, and we've got Fluor Construction talking about the Eli Lilly project down in Lebanon coming later this afternoon. We also have some panel sessions. We heard about AI this morning, and we're going to see the application of those chips and talk about that in construction. So we have an AI panel session going on in Stewart 218 at 10:30 a.m. And then later in the afternoon at 2 o'clock, we have a workforce development session, okay? So we've got some great industry panelists coming in to talk about both how AI is coming into construction and to talk about some of our workforce development issues here. Brad, did I cover that well? Okay, thank you. All right. A couple other items. It's been raining off and on, and you know, you've noticed our doors are closed now because of construction. Always building new things here at Purdue. There is a tunnel between this building and Stewart Center. Many of you have already found it, okay? We've been a little hesitant to talk about it because we don't want you to get lost in the maze of Stewart Center, okay? We don't want to lose anybody. But if you go out these doors and go downstairs, go out all the way to the main registration desk, go to the right, go down to where we eat lunch, okay? Rather than going towards the lunch place, if you go the other direction, it is a tunnel that will take you to Stewart Center. You'll go by our visualization lab, and then once you get through that area, you'll get into the Stewart Center, and then you can go up a floor and up to the different sessions there, okay? And stay nice and dry in the process. Many of you have already found it. My guess is there'll be a beeline out of here and when we start sessions to that area. Okay. The Mackey Arena tour for our guests, it's going to be meeting at 2 o'clock in front of the reception. So I mentioned this yesterday. If you want to go see Mackey Arena, for those of you that have guests, it is a great venue. Heather Hassenplug, I saw Heather here earlier. She is going to be out there at 2 o'clock to take you over to Mackey Arena. Okay. Still slots for Carb Day at Indianapolis 500. We do have a bus that we're taking down there, so if you're interested in that, go watch some fast cars on Friday. Just sign up at the registration desk. Okay, that's all I have. Okay, Mark, do you want to go ahead and come?
Just one, what was the room that you mentioned in Stewart for the industry?
The industry panel is in Stewart 218. That is correct, right? Yes, and it's in the app, Stewart 218 for the industry panel session on AI. Okay. All right, anything else, folks? All right, well, enjoy your day. We'll have lunch again down in the basement here. And as I said, we'll have our keynote at 4:30 with Fluor Construction. Thank you.